MPLS TE class-based tunnel selection or CBTS. In this video, I'm going to talk about another method of forwarding the packets into the TE tunnel. You know that in previous videos, we learned about 4 methods of the forwarding traffic into the TE tunnel. Let me to review it again. In this scenario, we are talking about the forwarding traffic, okay, into TE tunnel. Okay, I know that you remember these 4 methods. The first method that we use is the static routing. The second is PBR. Also, we learned about the auto route announce. Okay, and after that we learned about the forwarding adjacency. Okay, and I'm sure that you can configure all of these methods, and you learn about these methods and also the detail of, for example, concept of these methods, configuration of these methods, and so on. Okay, let me to talk about the next method. The next method's name is, as I mentioned before, class-based tunnel selection or CBTS. Okay, first, before starting the, for example, talking about this method, let me to say that you know that we have a course, and the name of that course is QoS, or a quality of service. Okay, in quality of service, we have some techniques for giving quality for some specific traffics, for example, voice or video traffic. Okay, the CBTS has a requirement or has a prerequisite, and the prerequisite of the CBTS is quality of service. If you know about the quality of service, you can use this video easily. But if you don't know, if you didn't study the quality of service, maybe in some part of this scenario, you will encounter with some problem about the knowledge. Okay, I recommend first study the quality of service, and after that watch this video. But if you want, you can for example, watch this video now, and after that you can study the quality of service course. You can watch my video about the quality of service. I talked about the quality of service. I explain many features in the quality of service video. Okay, because of that, the CBTS or class-based tunnel selection is a method with, for example, a route in the QoS course. Because of that, you need to know about the QoS. This is the first notation that is necessary to understand it. And after that, let me to talk about the CBTS. For better understanding the CBTS, I'm going to review some of the fundamentals topics of the MPLS. You know that in MPLS, okay, we have MPLS label, and you know that from MPLS fundamental course, the MPLS label has 32 bits length or 4 byte. Okay, let me to review this parts of the MPLS label. In MPLS label, we have 4 section or 4 parts. The first part, the first 20-bit length part, is the actual label, or the number that you are, for example, working with that number as a label. For example, 20, 30, 100, for example, 200, or some other values. Also, after the actual label, we have 3 bits, and we call these 3 bits EXP or experimental bits. After that, we have 1 bit, okay, and the name of that 1 bit is BOS or bottom of stack. And finally, we have TTL. Okay, it's necessary to understanding everything correctly and with detail. Because of that, you need to review some of the topics about the MPLS fundamental. Actual label length, as I mentioned before, is 20 bits. Okay, and after that, EXP bits has 3 bit, and BOS has 1 bit length, and TTL has 8 bits length. Okay, let me to write here EXP or experimental bits. Okay, I talked about all of these features in the for example, MPLS fundamental course. And BOS, okay, is the bottom of stack, okay, a stack of the labels. And also TTL, you know that TTL is the abbreviation of the time to leave. Okay. In this video, I'm going to talk about only EXP. I'm not we're going to work with the, for example, BOS or TTL. Okay. Here, the EXP is important for us. What is the EXP? And what is the usage of EXP? Its relevance, it has relevance to our scenario, the CBTS. Let me to review it. Look at here. If you want to understand the EXP, first you need to understand IPP or IP precedence. This is not about the MPLS. This is about the type of service or quality of service in the IP world. Look at here. You know that when we have a application data, for example, this is our data, we need to give this data to a protocol in transport layer in TCP IP, for example, TCP or UDP. After that, TCP or UDP should encapsulate the packet and give the packet, give the segment to the IP protocol to creating a packet. Okay, you know that IP should add a header to the, for example, original data, then TCP or UDP header, and after that we have IP header. You know it. Okay. In IP header, we have some parts, some fields. For example, the one of them is the destination IP, one of them is source IP, and one of the important parts of the IP header is the TOS byte. Let me to review the TOS byte. IP header has some field. One of them is TOS. Okay, TOS or type of service. Okay, TOS or type of service is a 8 bits length or 1 byte. Okay, length. Okay, has 1 byte length, and we are using the TOS for giving the priority, giving the quality to a special type of traffic. Okay, I'm not going to talk about the detail of TOS. If you want to learn about the TOS, you need to watch the QoS course. But let me to say that in TOS, in 8 bits of TOS, we have two important parts. The first part is IPP, and the second part, okay, is the next 5 bit. I'm not going to talk about that next 5 bit because this is not about our course. The first 3 bits is the IPP or IP precedence. You know that this, for example, first 3 bits IP precedence. Okay, these first 3 bits, okay, can be a value, can have a value from the 000 or 001 or 010 or 011 or 100 or 101 or 110 and then 111. This means that in the IP precedence part of the TOS byte, we can experience one of these 8 value. Okay, and here we have a logic. The logic is bigger, okay, is better. Let me to write it here. Bigger is better. What does it mean? Look at here. Assume that we have 2 traffic. The first traffic is data traffic, okay, and the second traffic is voice traffic. You know that the voice traffic has a higher precedence for us. Okay, these 2 traffic, okay, sending to one equal destination IP, for example IP1. Okay, this means that both of these packets now are sending to one destination, to a specific destination, and R1 can forward these 2 packets. Here, if you don't configure in the IP header the IPP, we don't have any difference between these 2 packets, but in some cases we need to give quality to voice. One of the methods that we can use, that method for giving quality to voice, is setting the higher IP precedence in the IP header for the voice. For example, let me to set in the IP header of the voice packet the value of 101 means 5 in decimal, and let me to set the IPP in the IP header of the, for example, data packet to 000 or 0 in the decimal. Now we have 2 packets with same destination IP but with different IP precedence. Because of that, R1 can understand that it should forward the packets faster, the voice packet faster than the data packet. Okay, and now you can see the logic of the bigger is better. Bigger IP precedence